Welcome to yet another video on SRID Cloud. In this video, I want to talk about network address translation with very simple topology. No LAN, no VLANs, no VRFs, very simple. So let's get started. So if you look at this topology, there are 4 networks in this. The bottom left side is 192.168.10 network with a couple of PCs or VMs or physical systems connected to a switch. And the switch is connected to a core router. The gateway for this network 192.168.11 is set on the core router on the southern side, and its ASN is set to 62,000. And the core router is connected to edge router with 172.16.10 network, with the dot 1 being the gateway on the southern side and dot 2 on the northern side. And the core and edge routers and switch and bunch of computers can be thought of as a data center. And now this data center is connected to an external router. Could be internet service provider or anything, whatever you can think of. And the external router is connected to the edge router with 10.140.10.0 network, with dot 10 being the IP address on the left side and dot 1 on the right side. And there is another experimental network connected to the external router, that is 10.20.30.0 network, with the dot 1 being the gateway for that network on the southern side of the external router, and a PC with the dot 2 IP address. So if you look at this diagram, think of it as I said earlier, the edge router, the core router, and then the switch from the left, or a part of a data center, and then the external router and the switch on the right are part of the external IT infrastructure. And these two networks do not know about anything, know anything about each other, and we have to connect them. For example, the PC1 on the top, the bottom left side, want to talk to the PC3 on the right side. But the network 192.168.10 and even the core router does not know anything about the 10.20.30 network at all. And similarly, the 10.20.30 network on the right side know nothing about the 192.168.10 network at all. So now with network address translation, it is possible to connect these two networks. So let's see how that is done. First of all, describing the topology again. On PC1, I have the IP set to 192.168.12. Let's verify that. And its gateway is set to 192.168.11. And similarly, on PC2, the IP is set to 192.168.13. And its gateway is set to 192.168.11. And now let's get on the switch and make sure all 3 ports are open. And the fast Ethernet 00, 01, and 02 are all up and running. As I said earlier, in this topology, I did not put any VLANs or anything like that, including VRFs at all. So now let's look at the core router and see some interesting things in it. Let's skip all these things. So here is the Gigabit Ethernet 1, which is connected to the southern side towards the switch, and its IP address is set to 192.168.1.1, which is the gateway for the network. And the Gigabit Ethernet 2 is the connectivity towards the edge router, and its IP is set to 172.168.1.1. And a BGP is set between core and edge routers. We could have done it without the BGP. Actually, we could have added a static route to 10.140.10.0 network between edge and external routers in core via 172.16.1.2, and we could have added a static route to 192.168.1.0 from the edge router via 172.16.1.1. But instead of that, I have done this router BGP. So the router BGP ASN is 62,000, and I described the neighborhood of remote ASN was 63,000, which is edge router, via 172.16.1.2, which is the IP on the southern side of the edge router. And I have simply said redistribute connected. So whatever that's connected to this router is distributed to the other side. And there's one more interesting, important thing that I would like to mention is a default route. So there is a default route from core router to the edge router, because if an incoming traffic is not known to core router, then it has to be sent to the edge router. This is done because later on I'm going to ping the bottom right side PC, which is 10.20.30.2 IP address, from one of these IPs at the bottom left side. That network is not known to the core router, so it has to be sent to edge router for the traffic to move forward. So that is why I added a default route 0000 via 172.16.1.2, which is the southern port on the edge router. So any traffic that is coming into the core that it does not understand about the destination will be sent to edge router. So this is very important to understand this. So that's it from for this core router. Now let's take a look at the edge router, and we'll see some equally interesting things in it. So here again, I have defined the Gigabit Ethernet 1 and 2. Gigabit Ethernet 1 being the southern port towards the core router, and its IP address is set to 172.16.1.2. And the Gigabit Ethernet 2 is the right side of the edge router towards external router, and its IP is set to 10.140.10.10. And to connect the edge and core routers, I have created a BGP, and that is with ASN number 63,000, and the neighborhood is set up as 172.16.1.1, remote as 62,000, which is the core router. And I have simply said redistribute connected. So connected, any network that is connected to the edge router will be distributed. And I have done three interesting things. First of all, let's talk about the default route. Another default route is set on this router to send any unknown traffic with a destination that is not known to the edge router to the external router. So this is important because the edge router does not know anything about the 10.20.30 network. So if somebody wants to send a traffic through edge router to 10.20.30.0 network, then it has to go to the external router. So to accomplish that, a default route has been added on the edge router. So now the NAT aspect of it. So the first statement, IP NAT inside source static, followed by 192.168.1.2 or 1.3, to 10.140.10.101 or 102. So what does it mean is any traffic that is hitting the edge router will, if the source IP is 192.168.1.2, it will get translated to 10.140.10.101. Similarly, any traffic that is hitting edge router with the destination IP as 10.140.10.101 will get translated to 192.168.1.2. So you need to visualize this. Traffic originating from, say, PC1 with the source IP as 192.168.1.2 and destination IP as 10.20.30.2, which is the bottom right side. That traffic will go all the way from PC1 to the switch to the core router. And to make the traffic move forward, I talked about the default route. So using the default route, the traffic will move forward to the edge router. There, due to these NAT statements, the IP address will get translated. The source IP will become 10.140.10.101. And that traffic will leave edge router, reach external router. Since external router already understands 10.140.10 network and also understands 10.20.30.2 IP address or 10.20.30 network, the traffic will flow all the way to PC3. And in the return trip, the destination IP will be 10.140.10.101. If you understand, when the traffic returns, the source IP becomes the destination IP becomes source, and so on. So that traffic will flow all the way to the external router. An external router understands what is 10.140.10 network, so it will send it all the way to the edge router. And in the edge router, the destination IP will get translated from 10.140.10.101 to 192.168.1.2. And edge router knows where is 192.168.1 network. So it will send it to core router, and then from there it will flow all the way back to the PC1. Similarly, if I initiate traffic from PC3 to the 192.168.1.2 IP address, I should not use the destination IP as 192.168.1.2, because if I do that, the PC3 will not know what to do with that. So instead of that, I should use the 10.140.10.101 address. So in other words, whenever PC3 wants to talk to PC1, it has to use the IP address 10.140.10.101 instead of 192.168.1.2. So this NATed combination has to be published. So whoever is consuming this topology should understand that to communicate externally or to communicate from external source into the data center, they need to use the appropriate IP address. If, for example, if PC3 wants to talk to PC2, then it has to use the IP address 10.140.10.102 instead of 192.168.1.3. With this NATing in place in the edge router, the traffic will flow through. So let's do some quick testing. Let me go to the PC3 first and try to ping both the 192.168.1.0 endpoints. So as I said earlier, I cannot do this 192.168.1.2 or 3. Instead of that, I have to do 10.140.10.101. Oh, sorry, I put 0. And it goes through. And similarly, I can try the other one. It goes through. Actually, this traffic is hitting PC1 or PC2, even though the ping IP address is something different, 10.140.10 network. And now let's go to either PC1 or PC2 and see if we can ping all the way to PC3. So ping 10 20 30.2, and it goes through. So now to explain this more, let me use Wireshark. So let me go and set up a Wireshark for the link between edge and external routers. And here it is. Let me filter only ICMP. Now let me go to PC3 and then try to ping 192.168.1.2 using the 10.140.10 network IP, the NATed IP. So ping 10.140.10.101. So as you can see, the packets in the Wireshark, the IP is getting translated 10.140.10.101. Let me look at the trace on the edge to core connectivity to explain this further. And let me filter only ICMP. And let me do this again. So now you can see very clearly that the address 10.140.10.101 got translated to 192.168.1.2. Comparing this with the other. So here the IP addresses are 10.20.30.2 and 10.140.10.101, and here it is translated to 192.168.1.2. So hope you understood the NATing, very simple termed NATing with this video. And in my next video, I will do a dynamic NAT, like using only one IP instead of two for both PC1 and PC2. So we're going to be creating a pool, and that pool will have only one IP address, and both PC1 and PC2, when they go out through edge router, we'll use that common IP address. Or if we desire, we can have a pool of say 10 IP addresses, and the PC1 and PC2 can go through edge router translated with one or two of the IPs from the pool. So thanks for watching, and I will get back to you all with another video very soon. Have a wonderful evening, and bye for now.